I love Animal Crossing, but I hate on-screen keyboards. So when I put this into this and saw this, I did this. But then, in my encyclopedic knowledge of Nintendo history, I remembered that in 2001, they released a GameCube controller with a keyboard built into it. There's just one tiny problem. It doesn't work with this game. But what if it did? What if we could use a microcontroller to intercept signals from the keyboard, then send simulated controller events to a real running GameCube to automate typing in Animal Crossing at a tool-assisted speedrun level? So here's the schematic. The GameCube uses 3.3 volt logic levels to communicate with peripherals. So for this project, we'll be using my favorite 3.3 volt microcontroller, the Raspberry Pi Pico. To connect the controller to the Pi and the Pi to the GameCube, I chopped up some high-quality controller extension cables I found online. Each of the GameCube's controller ports provides a 5 volt line, which usually provides power for rumble motors, but for this project, we'll repurpose it to power the Pi by tying it directly to the VSys pin. I also added a Schottky diode here, so we can plug the Pi into USB for flashing and debugging without worrying about backfeeding 5 volts to the GameCube. The inputs both get 1 kilo ohm pull-up resistors to pull their data lines high, which the controller pulls down to communicate using a series of high and low pulses. So, not the tidiest wiring in the world, but we'll hide it all away in this little box I picked up at the thrift store. My friend Max helped me drill some holes in it on the drill press, then I used a 3D printed filing guide to hand file the holes to fit the 2 controller output ports. All in all, I'm pretty happy with how it turned out. Next, let's talk software. When communicating with controllers, the Pi pretends to be a GameCube. On pins 3 and 4, it sends the controller reset command to both of the controller's 2 output ports, which respond with their individual device IDs. The purple plug identifies as a standard GameCube controller, while the gray plug identifies as a keyboard. And once they're identified, the Pi starts polling them for updates, which come in as 8-byte responses. When talking to the GameCube, the Pi does its best impersonation of a standard GameCube controller. It responds to the GameCube's controller reset command with the standard controller ID, and then things get a little crazy. The Pi holds a representation of Animal Crossing's 3-layer in-game keyboard in memory, and when a key is pressed on the physical keyboard, it calculates the shortest path between the current in-game position and the target position, then sends the GameCube all the necessary controller events to get there at superhuman speed. Animal Crossing has a surprising amount of typing in it, and I used to find these segments really annoying. But now, if one of my villagers gives me a gift, I go to the store, buy some stationery, and write them a thank you note. But as I continued to use this thing, I noticed one major shortcoming. While the alphanumeric keys are pretty easily mapped to their equivalent characters in-game, what am I supposed to do if I want to type the Greek letter mu, or the Old English letter thorn, or, I don't know, octopus? So, I did what any sane person would do and watched this 10-hour FreeCAD tutorial at 2x speed, then modeled the 7 keycap profiles to create 81 custom 3D printed keycaps that map perfectly to Animal Crossing's character set. Holding Shift switches between upper and lower characters like you're used to, but holding Alt switches from left to right. For some of the less frequently used characters, I bunched up 4 characters to a key. To access the top right character, you hold both the Shift and Alt modifiers. And once you know the rules, it's actually pretty intuitive. But if we're going to build an elaborate automation system just for Animal Crossing, why stop at typing? In Animal Crossing, town tunes are customizable melodies that play in a few different places throughout the game. While this is something you're encouraged to customize, in the past I've usually just said it once and then never touched it again. So I decided to automate town tune entry too. When you press Shift Alt Music Note, the Pi Pico sends a series of precisely timed inputs to set your town tune in like 5 seconds. The tunes that get entered are defined as text strings in this C++ header file, and you can use the D-pad or the keyboard's arrow keys to page between them. I've got a lot of hits in here, but right now, this one's my favorite. Next, let's take a trip to the local convenience store to talk about Nook codes. Nintendo used the Nook code system to distribute special items like this blue bench that says Nintendo on it. But now, over 2 decades since the game's original release, the algorithm used by the game to generate these codes is well understood, and you can find spreadsheets with codes for every compatible item on sites like Nookopedia. Of course, having a physical keyboard does make it a lot easier to enter these codes, but I decided to take things a step further. Pressing Shift-Alt-Key on the keyboard activates Nook code mode. And from here, you can type the name of any compatible item, and the Pi will try to find it in this ginormous lookup table. If there's a match, it'll clear the item's name and automatically enter the corresponding Nook code, giving you the item instantly. Animal Crossing purists might call this cheating, but in my view, this breathes new life into an old game. I used it to build this offshore workshop, where a crew of enchanted automatons create inventory for a wealthy industrialist. If you've played Animal Crossing before, then you know about the Able Sisters Design Studio, where you can input 32 by 32 pixel graphics to create custom clothing, wallpaper, and more. And I don't know about you, but for me, inputting over 1,000 pixels by hand gets tedious fast. For this one, I wrote a Python script that takes an arbitrary image's input, uniformly scales its lesser axis to 32 pixels, crops off the excess, and then converts it to use each of Animal Crossing's 16 15-color palettes. From there, it rates each conversion based on spectral and structural similarity to the original image, chooses the palette with the highest score, then writes the palette and color IDs for each pixel to this C++ header file. From there, the PyPico steps through the data pixel by pixel, sending all the necessary inputs to switch between palettes and colors. I actually think this is the most fun I've had with this game in a while. And I feel like I'm just scratching the surface of what's possible with this system. Speaking of what's possible, if we can render images, we should be able to play back video, right? Well, at 3 minutes to render each frame, we're hitting a video frame rate of about 0.0056 frames per second. So while we are technically playing a video right now, you might want to clear out your calendar. Bad Apple is still surprisingly legible at thumbnail image size. And if you've ever wanted to watch an approximation of Shrek really slowly, today's your lucky day. I actually half considered making it run Doom, and while that could technically work, watching this cursor snake around the edges of the screen gave me an idea. So here's a playable version of Snake in Animal Crossing. I chose to implement Snake over other games like Tetris, since it only needs to update 1 pixel for every frame of animation. And running at a healthy 1-ish frames per second, this probably isn't the worst version of the game you've ever played. Unlike those, this Snake isn't about reaction times and quick reflexes, it's more about commitment and perseverance. How long are you willing to keep going before giving up, getting distracted, or falling asleep? It takes a few seconds to travel from one side of the screen to the other. So you can send some inputs to get yourself lined up with the next apple, then sip some coffee, pet a dog, or respond to a work email. When you finally do collide with either a wall or yourself, if you were stubborn enough to get the high score, you'll be invited to enter your initials using the keyboard, immortalizing yourself in the annals of video game history for all time. Or at least until your PyPico loses power. The code and design files for this project are available right now on GitHub. If you'd like to support my work, consider purchasing a hand-printed postcard from my online store, Irving's Emporium. Next time on the show, lateral thinking with weathered technology. Stay tuned for more.